Solving series of kinetics problem, is it not? Let's get refreshed with few interesting MCQs in today's session. Well, it's Sanitara, geochemistry mentor, going to start with the first MCQ now. Let us see the first question. If the concentration is expressed in moles per liter and time in seconds, the units of rate constant for a first order reaction is mole per liter per second per mole. Okay. See, to answer this, you should know the general format for the unit of rate constant. Actually, it goes like this. Mole, this is the general format. Mole 1 minus n, liter n minus 1 and second minus 1. Okay, so this is the general format. Now in this you should substitute the value of n. Okay, in this where n is the order of the reaction. Since we are in need of the rate constant for first order reaction, we shall substitute 1 in the place of n. Okay, so we should substitute a 1, okay, for n, right? So let us see how to find it out. Mole 1 minus 1, liter 1 minus 1, S minus 1. See, this will be 0, this will be 0. So this becomes, so the final unit will be S minus 1, that is second minus 1. So option C is correct. Understood, students? Write the next question. DDT on exposure to water decomposes with a half-life of 10 years. How much time will it take it for the decomposition to 99% according to first order kinetics? Okay. See, the half-life period is given and they are asking you to find out the time that will be taken by this DDT for its complete decomposition, that is to 99% according to first order kinetics. Okay. So, and 4 options were also given. So, let me write the formula for the rate constant for the first order first. K is equal to 2.303 by T, okay, by T log initial concentration A, okay, initial concentration divided by concentration after time T, okay. So this is the formula for rate constant, okay. And now let me write the formula which relates this half-life period with that of the rate constant for the first order reaction. So rate constant K is equal to 0.693 by T half. So this is the formula which relates half-life with that of the rate constant. So now I am going to equate these two formulas, okay. So this formula goes like this, 0.693 by T half, okay. T half is equal to 2.303 by T log concentration of A by A minus X, okay. Now, see here I am going to substitute the values now. See, already we know T half is nothing but it's 10, is it not? So 0.693 by 10 years. It's not, it's 10 years, it's already given. That is equal to 2.303. So this is the time we want to find it out. So log, what could be the initial concentration? Actually in the problem it's given 99% completed, is it not? That means a percentage, since it is given in percentage, so let us consider the initial concentration as 100, okay? So initial concentration is 100 divided by 100 minus 99, okay? So 100 minus 99, right? So now simplify this, 0.693 divided by 10 is equal to 2.303 by T log, see here what happens, 100 minus 99, it's 1, is it not? So 100 by 1 is equal to 100, is it not? So log 100. So what is log 100? It is 2, okay. So it's equal to 0.693 by 10 log, that's equal to 2.303 by T 2, is it not? Since log 100 is 2 now. So when you are simplifying everything, you'll be finally getting 66.46. So when you are just getting into a whole number, you'll get 70. So 70 years, okay. So this is the correct option. Understood, students? Right, the next question. The rate of reaction increases with increase in temperature because of. See, they are asking you to find out the reason why the rate of the reaction is increasing with increasing temperature. So four options were given. The first one is increase in the number of molecules, whether this could be the reason, or increase in activation energy or decrease in the activation energy or increase in the number of molecular collision. See, actually, when the temperature is increasing, the number of collisions among the reactant molecules per unit time will be increasing. Understood? Hence, the rate of the reaction also increasing. So that's the reason. So increase in the number of molecular collision is the correct answer. Okay. So this will increase the rate of the reaction. Read the next question. In a chemical reaction, two reactants take part. Okay. See, there are two reactants taking part in a chemical reaction. The rate of a reaction is directly proportional to the concentration of one of them. See, it's given that the rate of the reaction is directly proportional to the concentration of the one of the reactant and inversely proportional to the concentration of the other. Okay, then they are asking you to find out the order of the reaction. Okay, so four options were given. So let me write from the question. Let us consider that the reaction be A plus B. Let A be one of the reactant and B be the another reactant, and this is giving the product. Okay. Now, according to the question, what's given? The rate of the reaction, that is, the rate of the reaction is directly proportional to the concentration of the one of the reactant. Is it not? It's directly proportional to the concentration of the one of the reactants. Let us have that as 1. Okay. And it is inversely proportional to the concentration of the other reactant. So here we can write as -1. Since it is inversely proportional, I am writing as -1. So this is the format. Okay. Rate is directly proportional to the concentration of one of the reactant, inversely proportional to the concentration of the other reactant. So now they are asking you to find out the order of the reaction. What is order of the reaction? Order is the sum of the powers of the concentration terms. Okay. It is the sum of the powers of the concentration. This is the concentration of one reactant and this is the concentration of other reactant. So order is the sum of the powers of the concentration terms of the concentration terms. Okay. So order, we are going to find out order now. Order is equal to 1. What is the power here? 1 plus, it is the sum, isn't it? It's the sum total, -1. So this is equal to 0. So the order of the reaction is 0. So option A. Read the next question. The temperature dependence of rate constant K of a chemical reaction is written in terms of Arrhenius equation. K is equal to A e power minus A by RT. The activation energy E of the reaction can be calculated by plotting. See, they are given the Arrhenius equation which relates the rate constant with that of the activation energy. Okay, and now they are asking you to find out by plotting which term and another term will be getting the energy, will be able to calculate the energy, that is activation energy. So what are the terms that has to be plotted to get the activation energy? Okay, see, let me write the Arrhenius equation first. K is equal to A e power minus EA by RT. Okay, see, when you are taking log on both sides, log K is equal to log A. Okay, A is nothing but it's the frequency factor minus EA by. So when you are converting, we are taking 2.303 R, okay, into 1 by T. Okay, so when you are taking log, we'll be getting the format like this. See, this equation is similar to the straight line equation. Y is equal to C plus mx. Okay, so when you are plotting, when this log K is plotted against 1 by T, we will be getting a straight line. Okay, so when you are plotting a graph between log K, okay, log K versus 1 by T, you will be getting a straight line. From this, you will be getting the slope. So the slope value is, if the slope value be equal to EA by 2.303 RT. Okay, so from the slope it is possible to calculate the activation energy. So when you are plotting a graph between log K and 1 by T, it is possible to get a slope from which it is possible to calculate the activation energy. So the correct option is log K versus 1 by T or a T inverse. Okay, so option A. So read the question, students. In a reaction A plus B giving product, the rate is doubled when the concentration of B is doubled. Okay, they are giving some what to say, clue, right? The rate is doubled when the concentration of B is doubled, and the rate increases by a factor 8 when the concentration of both the reactants A and B are doubled. Okay, the rate law for the reaction can be written. See, they are asking you to write the rate law, and they are giving two conditions. Okay, in which the first condition is the rate is doubled when the concentration of B is doubled, and in the second condition the rate increases by 8. Okay, when the concentration of both the reactants are doubled. Okay, so let us consider that the order with respect to A and B is alpha and beta respectively. Okay, the order of A with respect to A and B be alpha and beta. So if this is the case, we can write the rate of the reaction first in general. Okay, so rate is equal to K into concentration of A to the power alpha and concentration of B to the power beta. Okay, let this equation be equation number 1. Now, see the first condition. What is the first condition given? The rate is doubled when the concentration of B is doubled. Okay, now I am going to rewrite this equation based on this factor. Okay, so how this equation becomes? So 2 into rate is doubled. So it's not 2 into rate is equal to K into, so already it's given, concentration of A remains as such, but whereas concentration of B is doubled. When concentration of B is doubled, the rate is doubled. Okay. Now second one, the rate increases by a factor of 8 when both the reactants are doubled. So I am going to write again 8 into rate. So the rate is multiplied with 8K. Now here both the reactants are getting doubled. Okay, so I'm going to write like this 2B. Okay, up top we are going to write the order with respect to B. Okay, now see, now they are asking you to write the rate law. For that we should find out the value of this alpha and beta. Only then it is possible to write the correct rate law. Okay, for that, to find out alpha and beta, I am going to divide equation 2 by 1. Okay, so I'm going to divide equation 2 by 1. So what is equation 2? 2R is equal to K into A alpha into 2 into B beta. Okay, what is the first equation? It's simple, right? R is equal to K A to the power alpha B to the power beta. Is it not? So when you are simplifying like this gets cancelled, this gets cancelled, this gets cancelled, this gets cancelled, and finally you'll be having 2 2 is equal to 2B per B. Is it not beta? So beta, what is the beta value? So it's a similar, right? It's equal, right? Beta value is equal to 1. Okay, beta value is equal to 1, right? So we have found out beta. Now we are supposed to find out value alpha. Now for that I am going to divide equation 3 by 2. So when you are dividing equation 3 by 2, what happens? What is equation number 3? 8R is equal to K into 2A alpha into 2B beta. Okay, divided by, what is equation number 2? 2R. Is it not? 2R is equal to K into A alpha into 2B beta. Understood? Okay. Now after simplifying, this gets cancelled, and this becomes 4. Is it not? 4, and this gets cancelled, this one and this one gets cancelled. Finally you'll be having 4 is equal to 2A per alpha. This 4 can be written as 2 power 2, that's equal to 2A alpha. Now what is the value of alpha? Alpha is equal to 2, is it not? So alpha is equal to 2. Now we have found out the value of alpha, and also we have found out the value of beta, is it not? Now we can write the rate law. Is it not? What is the rate law now? Rate is equal to K into A. What is the value of alpha? It is 2, is it not? So 2 power 2, and what is the value of beta? It is 1. So this is the correct answer. So which option is having this format? Option D, is it not? Option D. So the next question, under which of the following a bimolecular reaction may become first order? See, four options are given: when reaction is in equilibrium, when activation energy is very high, when one of the two reacting species in large excess, when both the reacting species have the same concentration. Actually, the option C is correct because only in pseudo-unimolecular reaction, in pseudo-unimolecular reaction, in pseudo-unimolecular reaction, the bimoleculars become the first order. Okay, bimolecular both it becomes the first order. The example for this is hydrolysis of ester. In hydrolysis of ester, say we'll take ester plus water. Okay, water in the presence of an acid. Okay, we'll get the product, right? See here, the ester, obviously it is a bimolecular. Two things we are taking, ester as well as water. So it is bimolecular. But this water will be taking in excess amount. Since we are taking in excess amount, we shall ignore the concentration of water. Since we are ignoring the concentration of water, this bimolecular reaction becomes a first order. Okay, this only one substance will be taking into consideration. Concentration of ester will be taking into consideration, and concentration of water will ignore. That's why. So in this case, so this is an example for pseudo-unimolecular reaction. So when one of the reacting species is in large excess, the bimolecular reaction may become the first order. Understood, students? Hope. Well, fine, students. You might have understood all the questions and its relevant explanation I have given in this session. I shall meet with another important, interesting topic in my next video. Until then, it's Anita signing off from you. Thanks for watching.